Automotive manufacturers were requested to produce 75% of the engines needed for military aircraft during the Second World War, though only 2 of their operations undertook the task of constructing complete airplanes. Ford Motor Company manufactured B-24 bombers for the Army in a newly constructed, purpose-built facility at Willow Run, Michigan, while General Motors converted existing plants in New Jersey, New York and Maryland into carrier aircraft sources for the Navy. Although General Motors' endeavor has received less historical recognition than Ford's, it proved more successful by at least one quality measure. Its facilities consistently fulfilled the Navy's delivery schedules. Ford's production, conversely, fell behind for a period. General Motors' true competition, however, was located halfway around the world at the Zero fighter manufacturing plants of Mitsubishi Heavy Industries and Nakajima Aircraft Company, based in Tokyo. Just 6 weeks following Pearl Harbor, the Navy enlisted General Motors to produce both fighters and torpedo bombers for its carriers, as well as some for the British. Many of these aircraft were intended for the Pacific and inevitable confrontations with the small but lethal Zero fighters. The rapidly climbing, highly maneuverable enemy fighters initially surprised most Americans. Yet, when they appeared at Pearl Harbor, they were already battle-tested, having previously outperformed China's American, British, and Russian-built warplanes. To the Japanese forces, the Zero represented more than a weapon. It was almost a philosophical approach. The pilots who flew the single-seat fighters compared them to airborne samurai swords, and as Zero designer Jiro Horikoshi revealed after the war, Japanese military strategists originally believed 1 Zero would equal from 2 to 5 enemy fighter planes, depending on the type. Little more than a month after Pearl Harbor, waves of Zeros were already leading attacks on New Guinea and the Solomon Islands, gateways to Australia. Before that, they had supported invasions of Guam, the Philippines, Malaya, the Dutch East Indies, and Wake Island. Operating from island bases and aircraft carriers, they seemed to be everywhere in substantial numbers, escorting bombers and troop ships, attacking airfields and anti-aircraft batteries, and generally overwhelming the United States and British planes confronting them. Desperate to gain air-sea supremacy in the Pacific and to counter the German U-boat threat in the Atlantic, the Navy arranged an extraordinary partnership between giant General Motors and the much smaller, suddenly overcommitted carrier plane developer, Grumman Aircraft Engineering Corporation. The duo's mission, with General Motors in the unlikely role of secondary contractor, was to elevate America's naval aircraft production to the levels demanded by a two-ocean war. Curiously, the Navy's paired production strategy paralleled one the Japanese forces had already adopted. Since 1939, Nakajima, then the leading aircraft manufacturer in Japan, had been mass-producing the basic Zero, while Mitsubishi, the fighter's developer, concentrated on improved models. In the United States scheme, General Motors, not an aircraft firm but the world's top automaker, was contracted to assume production of Grumman Wildcats and Avengers so that the source company could work on a new, more advanced plane. The crucial questions for the Navy's Bureau of Aeronautics, the contracting agency, were: could General Motors apply the auto industry's celebrated manufacturing skills to plane making, and could that be done fast enough to affect the course of the war, particularly in the Pacific? There seemed to be little doubt about the answers at the leadership level. Donald M. Nelson, the nation's War Production Board chairman, maintained that, when the war started, there were not more than 3 countries, outside of the United States, whose entire industrial war-making potential was greater than that of the American automobile industry. According to General Motors chairman Alfred P. Sloan, his corporation's objective was to transform the world's largest automobile company into the world's largest manufacturer of materials for war, and in doing so to take on the most complicated and difficult production assignments. Nowhere was General Motors' expertise challenged more than in the East Coast operation set up to make the Grumman-designed aircraft. Plants at Linden, Trenton, and Bloomfield, New Jersey, Tarrytown, New York, and Baltimore, Maryland, were merged into an ad hoc General Motors division called Eastern Aircraft. The Navy's contract called for the new unit to produce its first fighters and bombers by the fall of 1942, meaning that it was being asked to convert from autos to aircraft in less than half the time it normally took to develop a new car model. To get started, Eastern had to first tear down some highly productive assembly and parts lines, ironically, the kinds of facilities that had attracted the Navy. Before the war, the Linden plant had been one of the world's most advanced car assembly factories, turning out Buicks, Oldsmobiles and Pontiacs at a peak rate of 1 per minute. Trenton, a hardware facility, had produced as many as 750,000 door locks, hinges, trim mouldings and the like per day. For the Navy, Linden would switch to assembling Wildcat fighters and Trenton to Avenger torpedo bombers. They were supported by a Delco Remy battery plant at Bloomfield and Fisher Body Chevrolet factories in Tarrytown and Baltimore. These plants were responsible for sub-assemblies, such as wings, tails, cockpits, and electrical systems. All of the plants had to undergo procedural and workforce transformations, as well as physical ones. Eastern needed to form a new supplier network of more than 3,000 subcontractors to obtain aircraft materials and parts. The division's 9,000 employees required retraining provided by nearby plane manufacturers, colleges, and vocational schools. And, because plane making was still a more manual process than automaking, the workforce had to be more than doubled and staffed, mainly with unskilled emergency recruits who required basic tools instruction. Eastern overall could best be characterized as an apprentice, or learning organization, in 1942. Its general manager, Louis Cliff Goad, said as much the following year in an article on the division's conversion written for Flying Magazine. "Let me confess at the outset that I am a Johnny-come-lately to aircraft production. My entire career has been devoted to problems of automotive manufacture, most of it in the accessory business. In the matter of how to produce spark plugs or batteries, I could speak with some authority. In the complex field of aircraft manufacture, I do not pretend to know all the answers. But for the last year, we have been finding them the hard way, working around the clock, immersed to our necks in machines, techniques, and nomenclature unknown to us 12 months ago." Goad and staff had come to their new business, steeped in the principles and practices of standardized mass production, the process of translating well-documented designs into precisely machined parts that could be rapidly joined into replicated products on mechanized assembly lines. Their reorientation began soon after Eastern Aircraft was formed, when they asked Grumman for complete parts lists and engineering data for the Wildcats and Avengers. In the automotive process, designers had normally directed material buyers and machine tool makers through fully detailed requisitions and drawings. At aircraft firms, however, extensive use was made of hand tailoring by highly skilled mechanics, guided by discussions with engineers and sketches. Purchasing requirements had often been communicated the same way. As Eastern unhappily learned, many of the specifications it needed were in workers' heads at Grumman's plants at Bethpage, Long Island, New York. Supervisors from each of the division's facilities were quickly sent to Grumman to dig for the information. They used every possible research approach, from asking questions, peering over shoulders and taking notes, to studying drawings and files, measuring finished parts and photographing components and assemblies. Key specifications were immediately phoned back to Eastern, which gave buyers there a head start in setting up the nationwide supply lines necessary to procure some 10,000 different aircraft parts. Grumman itself became Eastern's first supplier. Because the Navy insisted, for maintenance reasons, that the two manufacturers produce planes with interchangeable assemblies, it was decided that one more step should be taken to guide Eastern. Grumman shipped finished Wildcats and Avengers, with major parts held together by temporary fasteners, to Linden and Trenton, respectively. The parts could be easily removed for measurement and analysis by tooling machine designers, assembly line planners, and other engineers at Eastern. Unfortunately, this reverse engineering tactic only illustrated how soft aircraft standards were. Many of the model components did not conform to the specifications on Grumman drawings examined earlier, and some even differed from ready-made parts that the Long Island Company began sending to Linden and Trenton to help Eastern build its first planes. This snag in its search for basic data marked the lowest point in Eastern's first year of operation, according to the division's official history. Eastern was then in its third month, with only 6 left for delivery of its initial Wildcat and 7 left for the Avenger. Its production departments were ordered to construct the first few planes in the aircraft industry's job shop style, while the division's engineers painstakingly developed the data needed to tool up for mass production. The engineers adopted an idea that aircraft firms had borrowed from shipbuilders. They laid out full-scale outlines of the Wildcat and Avenger and doggedly, over a period of months, filled them in with drawings of the thousands of parts involved. Each of the parts was drawn to the exact size desired in production. Thus, purchasing and tooling standards were finally set and documented. While solving its startup problem, Easton was faced with a more profound dilemma, which Goad described this way. In the automobile, a given design is fixed over a definite and fairly long period. The design of a modern warplane is fluid. It can be changed on a moment's notice, and is. That is probably one point most of us in the automobile industry failed fully to appreciate in the beginning. Goad's words do not convey the jolt that his engineers felt when they realized a cornerstone of General Motors' practice freezing designs to maximize output would not be transferable to their evolving wartime operation. Easton began receiving Navy requests for changes in both Wildcats and Avengers, while still gearing up for production. A number of the modifications resulted from growing knowledge about the Zero, which in effect became a benchmark for the Grumman-Easton tandem in the early part of the war. For Easton, this was one more startup hurdle. It involved making 4,000 engineering revisions, beginning with the 11th Wildcat assembled at Linden. Though the stubby Wildcat could rarely match the Zero in one-on-one dogfights, it was rugged enough to expose some weaknesses in the enemy plane. As a Marine pilot at Guadalcanal put it, a Grumman Wildcat can sometimes take long-term fire from a Zero, but the Zero cannot take 2 seconds fire from a Grumman. The explanation came when Navy engineers had an opportunity to evaluate a captured Zero. Apparently, to achieve superior speed and maneuverability, Mitsubishi had minimized its fighter's weight, trading off armor plating in crucial areas such as the cockpit. Further, the Zero had not been equipped with self-sealing fuel tanks, which were standard safeguards in the Grumman-designed fighters. During its first 6 months of production, the division received orders for over 100 design changes, including adding more guns to the wings of the Avenger. To cope with such volatility, Easton abandoned a core practice of the auto industry. With locked-in car designs and large volume runs, it had been expedient to use highly specialized machine tools, each doing a single job rapidly and economically. To build ever-changing warplanes, Easton had to switch to more pliable machines capable of performing, or being converted to, different tasks. Over a period of months, Easton Aircraft was going to violate nearly all of the sacred precepts of mass production philosophy, but of these violations and compromises a new technique of manufacturing was born. The division's history noted. Goad presented further perspective during a press conference held in December 1942 to mark his organization's successful changeover to producing complete combat aircraft, the first such conversion of auto industry facilities in the nation. With General Motors chairman Sloan at his side, Easton's general manager began by establishing realistic expectations for his hybrid operation. It is safe to say we cannot now and probably never will see during this war mass production of aircraft as we knew it in the automotive industry. He told some 100 journalists in discussing the constant, even feverish improvements required in military planes. But, he reassured them, Easton's production would be high enough to meet the Navy's needs. Touring the Linden and Trenton plants, the reporters saw some of the reasons for Goad's optimism. Conveyors, monorails, and other flow-enhancing mechanization hallmarks of the auto industry were being put to work in the plane assembly process. Giving its impressions the next day, the New York Times wrote, "The task of changeover has been a colossal one. Of even greater significance than the physical and technical transformation is the success with which the techniques of scheduled flow of material through a plant have been applied to structures like fighters and bombers. Easton Aircraft is at once a testimony to the cooperation and the know-how of both aircraft and automobile management, and a harbinger of even finer performance for war and for post-war industry. Easton at that point had exceeded its production target for 1942 by delivering over 20 planes to the Navy, twice the number expected in its startup year. In its journeyman year, however, the target set by the Navy skyrocketed to 4 figures. The division was charged, in 1943, with driving its production high enough to relieve Grumman for full-time work on the ultimate Zero Eliminator, the new Hellcat fighter. Concurrently, Easton faced yet another conversion. The Navy needed a smaller, lighter, faster climbing version of the Wildcat for its versatile escort carriers, the baby flatops, comprising shortened flight decks on freighter-size hulls. Escorts were already being used effectively in the Atlantic by both United States and British fleets for convoy protection and air-sea pursuit of German submarines. They were destined to play a vital role in the island-by-island recapture of the Pacific, serving as offshore bases for planes, usually Wildcats and Avengers, supporting amphibious forces. Operating from the escorts, the new Wildcats would become feared island attackers during the second half of the war, much as the Zeros were earlier. The design for the model, called the FM-2, was handed off from Grumman to Easton early in 1943. By the end of the year, Linden had assembled over 300 FM-2s, plus 1,100 of the earlier Wildcats, the last FM-1s produced for the United States and British navies. For Linden, according to Easton's history, the Wildcat changeover was fully as great as changing from one year's model to the next in automotive manufacture, except that in this case the plant could not shut down to retool. Because of the Navy's escalating demands, there could be no production gap between models. In fact, Linden's output had to keep rising while a seamless transition was made. Just as the plant had intermingled Buicks, Oldsmobiles, and Pontiacs on its pre-war assembly line, it built FM-1s and FM-2s simultaneously for part of the war. Gradually, the former were phased out as greater numbers of the wilder Wildcats, Easton's nickname for the peppier FM-2s, were put into the production stream. As Linden engineered its non-stop cutover, Trenton was teaming with the division's other plants to keep up with soaring orders for the Avenger. The three-man torpedo bomber, one of the war's biggest single-engine planes, had fast become the heavy hitter on United States carriers after making its debut at Midway. With its 2,000-pound torpedo or equivalent bomb load, it could pound ships, submarines, and land facilities. The Avengers could not be readily manufactured under a single Eastern roof. The bomber's dimensions and their complexities, such as built-in bomb bays, motorized gun turrets, and folding wings, dictated that they be constructed modularly. Baltimore produced the tail sections, Bloomfield the electrical and hydraulic systems, and Tarrytown the cockpits and wings. Finished components were shipped to Trenton, where they were joined to fuselages on a final assembly line. 2 weeks before Christmas, 1943, Easton presented its 1,000th Avenger to the Navy, and the following month it assumed sole responsibility for the bomber's production. At a Trenton ceremony, the plant's manager promised that the next 1,000 Avengers would be delivered in one-third the time. The division's progress and confidence were manifestations of its transition from learner to sharer in the wartime aircraft industry. By 1944, all of its plants reflected General Motors' proficiency at developing coordinated, continuous manufacturing operations. The learning process that resulted from the cooperative effort of Grumman and General Motors was by no means a one-way street, wrote Richard Thrulson years later in his History of the Long Island Company. Grumman also learned from the General Motors production experts, particularly in the fields of tooling, automation, and production line dynamics. The lessons were opportune for Grumman, with its vast influx of inexperienced and unskilled workers. The machine and the system had to fill the gap created by a shortage of highly skilled labor. Grumman and Easton made a total of some 35,000 planes during the war, the bulk of the Navy's carrier aircraft. When their combined volume peaked in 1944, the second contractor's production exceeded the original contractor's. The Navy rated Easton's product quality as the equal of the best in the industry. Further, General Motors division by then was the highest producer of naval aircraft in the world, surpassing even Nakajima, whose output of Zeros and carrier-based bombers was being retarded by severe material shortages. Easton was the source of more than three-quarters of the nearly 18,000 Wildcats and Avengers delivered in the war years. Significantly, it became a top producer in time for the Navy's climactic Pacific offensive, beginning with the invasion of Kwajalein early in 1944 and ending with the occupation of Okinawa on the nation's doorstep. In mid-1945, aircraft out of Linden and Trenton supported every major attack and helped turn back the Navy at Leyte Gulf in the Philippines, in the war's last and biggest sea battle. Meanwhile, the once exalted Zero was headed for oblivion. Late in 1944, south of Leyte, 10 of the fighters carrying 550-pound bombs crashed down on a group of escort carriers, damaging several and sinking one. This was the first of many planned kamikaze attacks by Zero pilots. The suicide missions were partly the result of the peaking production lines at Eastern, Grumman, and other United States aircraft companies. As American warplanes improved and proliferated, they took control of the Pacific skies, reducing the Zero, with its few remaining experienced pilots, to a desperate role. The Zero's downfall is generally attributed to the Navy's Grumman Hellcat and Chance Vought Corsair fighters, but the Wildcats and Avengers must share the credit. Avengers, not a direct threat to the fighters, often undermined them by bombing their island bases as well as their carriers. Future President George Bush, one of the Navy's Avenger pilots, was engaged in raids on airstrips and radio facilities in the Bonin Islands when he was forced to ditch his bomber in September 1944. The next year, as the war moved closer to the nation, Avengers were used in some carrier plane attacks on Tokyo area airfields and airplane plants. By that time, Nakajima and Mitsubishi operations were being disrupted by regular B-29 poundings, which damaged factories and slowed supply deliveries, compounding the material shortage problem. In the end, after a considerable head start, aircraft manufacturers found themselves unable to produce enough reliable Zeros or other planes to defend their country against the superior United States-produced aircraft. In the spring of 1945, United States military planners in Washington, on Guam, and in Manila were putting the finishing touches on the plan for what would have been the largest and probably most costly amphibious attacks in history, the invasion. United States military planning called for an attack on the southernmost home island of Kyushu on November 1, 1945, to be followed, if surrender had not occurred, by an attack on the main island of Honshu about 1 April 1946. These attacks, dubbed Operations Olympic and Coronet, respectively, would each be larger than the day landings at Normandy in June 1944. The first invasion target, Kyushu, was about twice the size of Massachusetts, with a population of some 10 million. Operation Olympic called for 3 core landings on the southern portion of the island. From the landing sites, American forces would fight their way inland and link up to gain control of the southern half of the island, a line running through the towns of Suno on the eastern coast and Saito on the western coast. The southern half of Kyushu would then be used as a base for intensive air attacks and to support the subsequent invasion of Honshu and the march on Tokyo. In July 1945, feigned and real preliminaries for Olympic began. Some United States soldiers and airmen worked on the pros and scenarios for the complex deception plan called Pastel II. And Admiral William F. Halsey's Third Fleet, comprising 17 aircraft carriers, 8 fast battleships, 20 cruisers and 75 destroyers, started pounding the Japanese air and naval forces. On July 10th, Halsey's carrier planes struck Tokyo, encountering virtually no fighter opposition or anti-aircraft fire. Vice Admiral John Shafroth led 3 of the battleships and 2 heavy cruisers with their destroyer escorts to within 29,000 yards of the coast of northern Honshu. The Japanese forces could see them offshore. The Third Fleet was to continue this first phase of Olympic preparation from 28th July, X-Day -95 to 23rd October X8. General of the Army Douglas MacArthur, commander of the ground forces involved in the campaign, would use X and Y to designate the attack days, because day had been too closely linked with the European War, which he disdained. For the men of MacArthur's Sixth Army, the invasion became inevitable on 1st July when the Eighth Army took over the fighting on Luzon in the Philippines, so that the Sixth Army could regroup, re-equip and train for Olympic. Organized fighting had ceased on Luzon, although major forces still held out in the mountains. As the Sixth Army's 11 Army divisions and support forces got ready on Luzon for its final campaign, its 3 Marine divisions rehearsed landings at their bases in Hawaii and the Marianas. The United States Invasion Armada, which would be the largest ever to put to sea, began to assemble at ports throughout the Pacific. Altogether, the plan called for a total of 1,371 transport, cargo, and landing ships with a capacity to carry 539,300 personnel and 61,200 tanks and other vehicles. Several landing ship, tanks were fitted out as miniature aircraft carriers to launch and recover Piper Cubs, popularly known as grasshoppers, to spot fire for artillery after the guns went ashore. These ships would use a wire trapeze system named for its inventor, Army officer First Lieutenant James H. Brodie. Another 21 landing ship, tanks would carry thousands of units of blood and mobile blood distribution units. They, along with 4 evacuation transports, would carry wounded out of the beachhead area, either to major hospitals on Okinawa and Luzon, or transfer them at sea to white-painted hospital ships that would remain far offshore. Ordinarily, medical personnel did not carry arms. But a training document for the invasion noted that those going ashore would be trained and armed because the enemy would not recognize any invader as a non-combatant. The total carrying capacity of the attack fleet indicated, but did not define, the actual size of the ground forces that would be sent into Kyushu. The original planning by MacArthur's headquarters called for the Sixth Army to land 337,000 soldiers and 87,000 Marines in the attack and its immediate follow-on operations. Those numbers, however, would periodically change as the planning progressed, as Army and Marine Corps unit organizations were changed, and as additional troops were assigned to the Corps and Army commands that would participate in the landings. General MacArthur, in a message to Washington in mid-June 1945, used 681,000 as the total force involved, with one half engaged the first 15 days and the entire strength thereafter. But his authorized post-war description of invasion plans, while discussing manpower in the broad army terms of corps and divisions, did not produce an overall number. The Sixth Army, the command making the attack, listed the landing force as 337,000 soldiers and 87,000 Marines and sailors in the attack and the immediate follow-on operations. MacArthur's Chief of Engineers used 549,503 as the total force to be landed, including engineers to build airfields and port facilities, Army Air Forces personnel to fly and maintain many hundreds of aircraft, and men to garrison the southern half of Kyushu, to operate military prison camps, and to provide services and military government for the captured civilian population. But this figure did not include the 3 divisions of Marines, since they would provide for their own engineering needs. Another planning document, which listed Sixth Army invasion units down to scout dog platoons, gave the total, including the 3 Marine divisions, 59,898 men, as 382,937. To this was then added 49,382 medical base construction, quartermaster and other service troops, 18,970 men assigned to military government tasks, and 35,857 men from the Far East Air Forces. When all of these numbers were added up, the total was 487,146, still far from the figures that MacArthur gave to Washington, or the ones used by his Chief of Engineers, but still an impressive force. MacArthur's 681,000 figure could have been obtained by adding the men of Navy and Army Air Forces supporting the invasion. While this massive force was being assembled, plans were drawn up for Admiral Halsey's Third Fleet to focus on aircraft, airfields and shipping between Honshu, Shikoku and Kyushu between 18th and 24th October. On the 24th, 2 of his carrier groups would join the Fifth Fleet under the command of Admiral Raymond A. Spruance. This was the first time since early 1942 that the 2 admirals and their fleets would be at sea fighting simultaneously. The Fifth Fleet would include the British carrier force and, as assigned, anti-submarine and logistics groups. The Fifth Fleet would have the amphibious ships, covering and support forces, minesweepers, support ships and a wing of flying boats and their tenders. Also present off Kyushu would be the Seventh Fleet, under Admiral Thomas C. Kincaid, which would be assigned ships and missions as appropriate by Admiral Chester W. Nimitz, the overall naval commander in the Pacific, and other commanders. Beginning on 24th October, X-8 battleships, cruisers and destroyers would begin bombarding the landing beaches, trying to knock out the elaborate coastal defenses. Among the 11 old battleships moving in to pound the landing sites with 16-inch and 14-inch guns would be 7 resurrected veterans of the attack on Pearl Harbor. The effectiveness of shore bombardment had long been debated. Some, but rarely all, coastal defense positions were destroyed in the various naval bombardments in the Pacific amphibious attacks. Still, some were destroyed, and bombardments immediately prior to the landings invariably forced the defenders to cower in their bunkers, generally preventing them from firing on the landing craft. The Olympic plan called for MacArthur's Far Eastern Air Forces, under General George C. Kenney, to cut off northern Kyushu from the invasion area to the south. Kenney's fighters and bombers were to take out the railroads and the paralleling Kokudo, or National Highway, a two-lane gravel road that ran along the coasts and linked the island's cities. The railroad seemed to be particularly vulnerable, for its tracks ran across numerous bridges and through tunnels. The highway and railroad network had so far remained solid enough for thousands of defenders to pass to the south. On 27 October, X5, elements of the Army's 40th Infantry Division and the 158th Regimental Combat Team were to begin landing on small islands lying off the west coast of Kyushu. These units probably would have met little opposition because the Japanese forces planned to throw nearly all they had into a fierce shore defense of Kyushu itself. The islands would be used for small craft to support the landing and as advance bases for PBM Mariner flying boats, which would perform reconnaissance and search and rescue missions. Subsequently, on X Day, the attack elements of 9 divisions would storm ashore on 3 Kyushu beaches. No one expected that landings on any of these beaches would be unopposed, as had happened on some other island attacks. Indeed, United States intelligence revealed that the Japanese forces referred to their defense of Kyushu as the decisive battle. The Japanese military leaders hoped to inflict enough casualties on the attacking armies to force and the United States to enter into negotiations to end the war. The Japanese forces intended to start their defense at sea, sending kamikaze aircraft and Bacchus-piloted, rocket-propelled bombs launched from bombers out to the invasion fleet as it approached the beaches. Submarines carrying Caton's torpedoes, carrying a pilot who used a periscope to navigate toward the target, would try to fire their human torpedoes as the fleet massed between Okinawa and Kyushu. Hundreds of Catons would go to sea. Japanese conventional submarines, they still had 60, would take suicidal chances to score an elimination, as would the midget submarines, which were not suicide weapons but probably would have been used that way in the decisive battle. Other midget submarines were to be stored in well-camouflaged shore-side caves and tunnels, from which they were to be launched on rails for one-way raids on the invasion fleet. Closer in, and probably during the landings, suicide boats would strike. Roaring out of hiding places as landing craft neared shore, the explosives-laden boats would aim at any craft carrying troops. The Navy's Shinyo carried 550 pounds of explosives in its bow. The Army's Renrakuti carried 2 240-pound depth charges, set to explode 6 seconds after release. Finally, there would be the usual underwater obstacles designed to rip open or hang up landing craft, as well as rows of fukuryu, swimmers in diving gear operating 30 feet or so beneath the water. The outermost row of the suicide frog men would hover near rows of mines anchored to the bottom. As the craft neared the mines, the fukuru divers would release them. Many of the divers would die in the subsequent explosions, and the survivors would carry mines to landing craft that passed nearby. Some would have explosives attached to poles they would jam against the sides of landing craft. The suicide planes would probably be held back until the invasion fleet was 20 or 30 miles from shore. The aerial suicide attacks would intensify around X Day when the fleet was taking up stations for the invasion. Plans were to have 10,500 kamikaze aircraft ready for massive attacks by early fall. At the end of June, 8,000 had been prepared for battle. Japanese strategists, basing their optimism on magnified reports of kamikaze and Baka successes in the Philippines and Okinawa, estimated that special attackers would take out 30 to 50% of the invasion fleet. Captain Rikihei Inaguchi, an air staff officer, was more guarded. He estimated that in the Philippines, only 1 of every 6 kamikaze planes hit a target. At Okinawa, the rate was 1 in 9. Off Kyushu, against intense United States fighter opposition, he expected a success rate of about 10%. Once ashore, American troops would be confronted by a Japanese army on Kyushu numbering almost 600,000 men. Many of the combat units, however, were newly formed, and the troops poorly trained and short of weapons and equipment. Short rations would also sap their fighting strength. But the tenacious defenses of Iwo Jima and Okinawa, which included paramilitary units, indicated that these men, some elderly and some just boys, would fight. Behind them, the civilian population would do its part, men and women who were armed and trained to throw themselves against the enemy with satchel charges, bamboo spears, and even kitchen knives. The estimates of United States casualties in the Kyushu landings varied greatly. For an 18th June 1945 meeting of President Truman and the Joint Chiefs of Staff, General MacArthur, who would command the landings, sent his casualty estimates, a total of 95,000 casualties, dead and wounded, for the expected 90-day campaign to seize the southern half of Kyushu. Not included in MacArthur's casualty number were another 12,000 non-battle casualties, men who would fall out of the ranks because of disease and accidents. The Army Chief of Staff, General of the Army George C. Marshall, feared that so high a casualty rate would make Truman put off the invasion. MacArthur lowered his estimates. The Joint Chiefs Planning Staff also prepared casualty estimates. One put the casualties as high as 132,000 men eliminated and wounded for the conquest of Kyushu. Almost 100,000 more Americans would be eliminated and wounded if the landings in Honshu followed, but these were, at best, educated guesses. Many numbers were discussed at the 18th June meeting in the White House, leaving the impression that American casualties might reach as high as 250,000. President Truman continued the discussion of casualties in the Berlin suburb of Potsdam in July 1945, where the president met face-to-face, for the first time, with Soviet dictator Joseph Stalin and British leader Winston Churchill. After learning details of the success of the atomic bomb test at Alamogordo, New Mexico, Truman met with his principal advisers on 22 July. It was apparently at this meeting that Truman wrote, "I asked General Marshall what it would cost in lives to land on the Tokyo plain and other places. It was his opinion that such an invasion would cost at a minimum 250,000 casualties and might cost as much as 1 million on the American side alone, with an equal number of the enemy." The casualty numbers discussed at Potsdam added to Truman's growing conviction about the need to use the bomb. 500,000 was a number used at the time by many United States wartime planners. On Luzon, the Sixth Army's medical staff, isolated from the politics of both Washington and Manila, estimated that casualties from the Kyushu attack and subsequent fighting to secure the southern half of the island would cost 394,000 Americans dead, wounded, and missing. At Okinawa, in a battle that offered many similarities to the fighting on Kyushu, the United States 10th Army suffered 7,613 soldiers and Marines eliminated and missing, and 31,807 wounded. Using that same 1-to-4 ratio for the Kyushu battles, the 6th Army could expect some 98,500 dead and 295,500 wounded. Thus, there is no simple answer to the question, how many would have died, if the war continued with American landings on Kyushu, possibly followed by an attack on the main island of Honshu. Only briefly mentioned but not discussed, at these meetings were potential casualties at sea. At Okinawa, the Navy suffered 4,907 dead and 4,824 injured on board ships, most struck by kamikazes. Off Okinawa, the primary targets of the Japanese attackers were destroyers, which served as radar pickets. The Japanese forces hoped to sink the destroyers to permit attacks on the transports offshore. At Kyushu, the Japanese targets of air, sea, and underwater suiciders would be the transports, cargo ships, landing ship, tanks, and landing ships. Unlike the destroyers at Okinawa that were maneuvering and firing at attackers with their heavy gun batteries, the target ships off Kyushu, some packed with troops, would be moving slowly, if at all, as they disgorged troops and equipment, and the kamikazes would have to fly only a few miles offshore, not the 350 miles to Okinawa. Some estimates placed the losses off Kyushu aboard ship, both sailors and embarked troops, at 10 times the losses at Okinawa. In Olympic, the suiciders might eliminate as many as 50,000 crewmen and troops, and wound an equal number in ships and landing craft. Also not mentioned in most discussions of casualties are the estimated 100,000 Allied prisoners of war. There is abundant evidence that the prisoners of war would have been eliminated when American troops landed. But there was no invasion. At Potsdam in July, President Truman approved the use of atomic bombs. On 6 August, the B-29 Enola Gay dropped an atomic bomb on Hiroshima, and 3 days later, the B-29 Boxcar dropped an atomic bomb on Nagasaki. At noon on the 15th, the voice of the Emperor was heard for the first time on the radio. In a recorded broadcast to his people, Emperor Hirohito declared, "To our good and loyal subjects. After pondering deeply the general trends of the world and the actual conditions obtaining in our empire today, we have decided to effect a settlement of the present situation." Then, referring to the immediate cause of his declaration, the Emperor continued that the war situation has developed not necessarily to our advantage, while the general trends of the world have turned against her interest. Moreover, the enemy has begun to employ a new and most cruel bomb, the power of which to do damage is indeed incalculable, taking the toll of many innocent lives. The largest amphibious attacks ever to be planned, Olympic and Coronet, would not be undertaken. Rather than support the invasion, Navy shore and carrier-based aircraft began crossing the skies over Japan, seeking out prisoner-of-war camps and dropping bundles of food rather than bombs. On 14th of August, World War II's fighting stopped. Planes launched on combat missions were recalled, though pilots already engaged fought through their last combat actions. Combat air patrols maintained by Task Force 38 would also claim a few more enemy planes as individual Japanese pilots made last runs against the fleet. But for the task force, as for the rest of the world, the long and hard-fought war had come to an end. Build-up of the greatest amphibious force ever to be assembled to conduct Operation Olympic could stop. No invasion of Japan's home islands would be necessary. In ships of the fleet, on island bases and wherever Allied soldiers, sailors, and Marines were located, as the word was passed, celebrations were the order of the day. Whether exuberant or quiet, each individual's reaction reflected the fact that a whole new future lay ahead. Back in the States, it was as if the whole country were participating as one in the jubilation. While a few dramatic incidents got media attention, for the most part it was a simple outpouring of relief, thanksgiving and joy that the war was finally over. While preparations for the occupation and the actual signing of the surrender documents went forward, it was almost impossible to believe that the patterns of life which evolved over nearly 4 years were about to change dramatically. Military or civilian, there was a general feeling that everything could go back to the way it was. However, at the same time, there was a realization that with the years which had passed and the events of those years, from the smallest and most personal to the advent of the atomic bomb, the past could only be memories. Today, the magnitude of the assembled Allied forces is hard to envision. Total naval aviation, from which the Pacific forces were drawn, numbered nearly 440,000, almost 100,000 of whom were officers, including 60,000 pilots. Less than 500 enlisted pilots still maintained that long-time tradition. Of the 440,000, 110,000 were Marines and 1,500 were Coast Guard, which was part of the Navy during wartime. These personnel operated a total of 41,000 airplanes, 28,000 of which were combat aircraft, 10,000 in the Pacific Fleet. 26 fast carriers and 64 escort carriers were available to carry Navy and some Marine carrier-based squadrons into battle. Task Force 38, operating against Japan on the last day of the war, was only one component of the total naval forces. Surface forces, submarines, Fleet Air Wing patrol planes and marine bombers all played a part. The task force's 9 regular carriers, each with its air group, 6 light carriers with their aircraft, and an integrated British Royal Navy carrier and air group comprised the most concentrated naval thrust, but only a part of the total Allied fighting force. Fleet and shore activities at home and in the war zone quickly shifted to new modes. Some, like the organization of separation centers, training of personnel to man them, and the actual demobilization process, had long been planned and already been initiated. Others, like the occupation of Japan, the freeing and repatriation of prisoners of war held by the Japanese forces, and the surrendering process for the military garrisons in Japan's occupied countries, were quickly planned and put into action, as were the preparations for the formal surrender itself. Recovery of prisoners of war began almost immediately, with as many as possible flown directly to Guam. Both Army and Navy planes dropped food and other necessities to prisoner-of-war camps that could not yet be taken over. The 2nd of September saw the formal surrender documents signed on board Missouri BB-63, with a tremendous flyover of Navy and Army aircraft. By this time, the flow of combat equipment into the Pacific theater had been reversed, but the issue of how to get the military personnel home remained. Available warshipping could not do the job for the veterans anxious to resume their civilian lives. While carriers heading back could accommodate large numbers of sailors if aircraft were left behind, a more direct project was established to expedite the overall troop return, Project Magic Carpet. Combat ships were modified to accommodate maximum numbers of military passengers and to shuttle back and forth. With troops still to be returned from Europe as well, these could be used for both Atlantic and Pacific transport. With their extensive hangar spaces, carriers and seaplane tenders were particularly effective. As an example, the seaplane tender Albemarle AV-5 had multi-stacked bunks in its hangar bay, with other spaces converted to heads and mess facilities. Carrying 2,000 passengers on each trip, Albemarle returned 6,000 military personnel to the West Coast during the fall months. Some of the newer escort carriers, CVEs assigned to Magic Carpet duty, never did get to operate aircraft, since most of the CVEs were rapidly tied up in reserve status. As United States bases throughout the war zone were relinquished, military material was processed for retention, destruction, or release for local use. Combat aircraft in at least one case were simply pushed off a cliff into the sea as the Navy pulled back from its far-flung bases. Marine squadrons accompanied the Marine ground forces deployed in China as the rising conflict between nationalist and communist factions flared into civil war. 7th Fleet escort carrier-based aircraft, as well as river-based patrol flying boats where airfields were not available, also covered activities in China. While the United States supported the nationalist side, military forces were restrained from directly participating in a combat role. Within the United States, disestablishments became the order of the day for units and bases other than the separation centers. The Carrier Qualification Training Unit at Glenview 3rd was one of the first to go, followed by decommissioning of the 2 Great Lakes training carriers, Wolverine and Sable, ending a unique chapter in naval aviation history. Throughout the country, air stations were closed and turned over for civilian use, particularly the smaller National Association of Academies of Science and Naval Auxiliary Air Facility auxiliary stations and fields, as well as outlying training bounce fields. Officer and enlisted personnel were released according to a common system for all services, taking into account length of service, extent of combat duty, and other factors. Programs to convert reservists to regular service were established, and pilot and other specialized training continued on a reduced scale as operational organization and training activities reformed at peacetime levels. On the East Coast, training for the 2 battle carrier air groups to operate from Midway CVB-41 and Franklin D. Roosevelt CVB-42 was a priority activity in preparation for shakedown cruises on both ships after their commissioning. In November, the training command was reorganized. Among the 4 subordinate commands was a new Naval Air Reserve Training Command. The new command moved rapidly to organize and initiate the post-war reserve program, which was designed to maintain wartime skills for a peacetime reserve force, using specially maintained bases or operating at major air stations. With production of everything needed for the planned invasion continuing at its peak rate, contracting offices worked overtime, getting out stop work and contract termination orders. Following an overall government policy, contractors and their subcontractors for all military hardware stopped work, and production workers were given time off while decisions were reached on what next. Since there were adequate numbers of most major aircraft models in inventory for peacetime use, their production lines never resumed. Workers returned to finish airplanes being readied for delivery and to assess the assemblies and parts coming down the lines for retention as spares or for salvage. This was followed by scrapping most of the tooling. Automobile companies, such as General Motors with Avengers and Wildcats in production and Bearcat production starting up, were more than eager to fully return to their regular products, as were appliance manufacturers, many of whom were major airframe component suppliers. Having initiated engineering work for commercial models, most of the aircraft companies were anxious to move these efforts along to beat the competition into the anticipated new air age. Carefully selecting the models, the Bureau of Aeronautics continued limited production of ongoing and newly developed models. Included were advanced production models of existing types, such as VOTS 4U-4 Corsairs, and new types such as Grumman F-8F Bearcats. With planned transition to new models then under development, such as the single-place VBT, later to be redesignated VA attack types, production of current models was dropped. The SB2C, TBM, and even the new TBY were closed out. Even though production of a new model under development was anticipated, low-level production of an existing model was continued in some cases to maintain the production base, regardless of adequacy of the existing model. And production schedules, both in number and timing, were adjusted to fit the development project's status. While most production was being cut back, McDonnell Aircraft, with a production contract for its first Phantom, the FD-1, later FH-1 jet fighter moved into the former Curtiss-Wright St. Louis, Missouri plant, left vacant in July as production of Curtiss C-46 R-5C transports was cut back after VE Day. Carrier construction was also adjusted. 2 of the 3 battle carriers underway were completed and commissioned, Midway at the Norfolk, Virginia, Navy Yard in September, and Franklin D. Roosevelt at Brooklyn, New York, a month later. Completion of the 3rd, and of the incomplete Essex-class carriers, was rescheduled for later dates. Experimental aircraft programs were reviewed and most were continued to completion. Flight testing of prototypes at low priority was continued to assess the potential contribution of their design features to future designs. Prototype development and production build-up for planned replacement models already in flight testing, such as the McDonnell XFD-1 jet fighter, Douglas XBT-2D1, later AD and A1, XBTM-1AM and XP-2V, later P2, were given higher priority. While production of the composite piston and jet engine FR-1 Fireball was terminated, development of the XF-2R1, similar but with its R-1820 Cyclone replaced by a GE TG-100 turboprop, was continued in support of planned production development of a similar F-2R2 turboprop plus jet fighter. While a flight test accident destroyed the first of the 3 XFD-1s in November, the second was already flying, and the program continued with only limited delay. Behind the scenes, many ongoing and new projects aimed at enhancing the performance of new technical advances were pursued, both to bring Pratt & Whitney into jet engine production and out of concern for Westinghouse's ability to meet production schedules of the 19XB engine for FD-1 Phantoms, while developing the 24C of nearly twice the power for newer jet fighters then being designed. Pratt & Whitney became co-producer of the 19XB. The application of the high-powered airborne early warning radar successfully operated by the fleet in carrier-based TBM-3Ws to a true airborne combat information center system in Boeing B-17s modified as radome-fitted PB-1Ws under Project Cadillac was a major step on the way to today's airborne warning and control system. Exploration of space rockets and development of rocket motors, one of which would later power the Air Force's Bell X-1 through the sound barrier, and joint development of the initially jet engine-powered Douglas D-558 series of high-speed research aircraft with the National Advisory Committee for Aeronautics, predecessor of today's National Aeronautics and Space Administration, were among the innovative concepts and approaches that could enhance future fleet combat effectiveness. Wartime experiments were also continued with pilotless aircraft, really guided weapons, of many types. As 1945 wound down, naval aviation had gone through some major transitions. There was little question that wartime experience had demonstrated aviation's new importance in the Navy, but not all of the post-war signs were positive. Though typical throughout the military services, the near decimation of fleet aviation was a cause for concern. Since VJ Day, naval aviation's total combat aircraft had decreased by 1/3 to 19,000. A better indicator of operating force decline was the decrease in operating combat aircraft to 1/2 of the final wartime number, and of these the number in the fleet was down to 1/4 of the VJ Day total. More than half of the carrier air groups and all of the light carrier air groups had been disestablished. Of those flying from Task Force 38's fast carrier groups on the last day of the war, only one was still active. More unsettling to naval aviation personnel directly was the upsurge in proposals for unification of the military services, seen as a new bid for the Army Air Forces to become independent and take over military aviation. In mid-December, an interpretation of remarks by President Harry Truman led to a directive that Navy officers could not speak out on the subject in public. The President himself stepped in to correct the interpretation, and the directive was rescinded at the end of the month, passing on his statement that views were to be understood as personal and did not necessarily reflect those of the administration. On the plus side, the opening of the Aviation Fundamentals Ground School under Naval Air Technical Training Center, Jacksonville, Florida, indicated that new blood was entering enlisted ranks. 12 weeks of generalized aviation instruction would give boot camp graduates seeking aviation duty a head start. 2 last-day-of-the-year actions closed out wartime chapters. The Coast Guard was transferred back to the Treasury Department, and the radiation laboratory run by the Massachusetts Institute of Technology, which had led the way on many radar advances, was closed down. With continued Navy interest in high-powered airborne radar, the Cadillac project and personnel were reformed as the Naval Research Laboratory Field Station to continue Cadillac Second. As calendars were turned to 1946, much of naval aviation's readjustment had taken place. Most of the veterans who would be released from service were back in the States, and Magic Carpet's job was essentially over. The carriers and seaplane tenders could be returned to their primary combat configurations, many, including most of the CVEs and the famed Big E. The pre-war Enterprise CV-6 would be tied up and readied for mothballing in the reserve fleet. Regular Navy and lower point reservists were integrated into operating units, and typical wartime troop train loads moved from West Coast to East Coast air stations to balance available manpower. New recruits on flight lines and in training command classrooms became more numerous. Planning was being conducted for fleet operations later in the year. These would include February's Operation Frostbite for cold weather tests above the Arctic Circle, during which both wartime and the latest carrier aircraft, along with a helicopter, would operate from Midway. Far more ambitious and significant would be the summer's Operation Crossroads, testing the atomic bomb's effects on naval targets at Bikini Atoll. Reorganizations continued. Navy photography was transferred from Bureau of Aeronautics to the Deputy Chief of Naval Operations, Air. Bureau of Aeronautics organized its material functions into 2 groups, recognizing the increasingly complex technical issues in research and development and the need to stretch reduced resources to the fullest in support of the fleet's aviation material. Fleet air wings and other units would continue to be disestablished, while smaller air stations would be turned over to civilian use. On the other hand, looking ahead, the Naval Aviation Ordnance Test Station was established at National Association of Academies of Science, Chincoteague, Virginia, and the Bureau of Ordnance's guided weapons work was transferred there, taking advantage of its out-of-the-way location and available sea ranges.